Question 1. Find a so that the above defined is a valid joint density function, and we know that fxy, xy, the joint density function is 1 plus xy over a. So according to the definition, we can get that in the definition area, the integral of xy should be 1. So xy should be the definition here is from -1 to 1, a 1 plus xy over a dx dy. Should it be equal to 1? So it's very easy for us to get that a is equal to 4. Question 2. Xy uncorrelated. Show your answer. We know if c is equal to ey minus exy, and we know ex is equal to x fx dx, and it's also equal to fxxy dy x dx. So and we already know that this should be the definition here. Y is and then this part is, we can guess it should be this part is 0, and this part is, so it becomes, and finally we can get ex, the mean of x is equal to 0. It's very easy. So the thing we can get the mean of y is also 0. Question 3. So then we can get exey 0 and exy. We also can get it's 1 over 9. So c is not equal to 0. So it's not uncorrelated. Xy independent. We know that if x is equal to 0, 1 over 2, if y is equal to 1 over 2. So it's easy to see that fxy is not equal to fxx plus fyy, so it's not independent. Question 4. Find the joint density function of the square of x and the square of y. So now we can get assume that z is equal to zx, the square of x, and w equal to the square of y. So we can find jxy. It should be so we can get that fzw, the joint density function should be fxy, xy. Here x1 since every function has two roots, so there are four combinations. There are four the j x y, so we can get it should be or like this, and fxy, and we know it is jxy and we can know that where x1 is equal to x2 is equal to 1 is equal to y2 is equal to so we can easily get that it should be this. So this is the joint independent function of x the square of x and the square of y. And the last question, prove or disprove that the square of x and the square of y are independent. And we can get FGG just from we already know that ffx, so we can get it through this in this way, and where gx is equal to the square of x, so it has two roots in the definition area. We can easy, so we can get where x1 fxx so here we can get no 2, so we can get it's equal to this. Also we can get that fww is equal to, so it's easy to see that this fgg, the joint independent function, is equal to the fgg, the density function of g, plus the multiply the density function of omega. So we can include that the square of x and the square of y is independent.